complete combustion, delta H combustion is negative 4163.2 kilojoules per mole of hexane. Do you understand how I got that number?
Yeah, it's the like the energy released from the combustion.
It's the energy released divided by the coefficient in front of my fuel.
Oh, so
So I took this is my delta HR,
yeah.
but I want molar enthalpy.
Okay.
So I took my delta HR and I divided by the number of moles of hexane.
So it's just the same number though, because this is 1 mole.
Because it's 1 mole. What would you do if I said, ladies, represent this as a molar enthalpy with respect to CO2? What would you do? If I had said, represent that same information with respect to CO2, you would divide by 6, because there's 6 moles of CO2. Make sense? Okay. So that's complete combustion. They want you to figure out now for incomplete combustion, but they don't give you the delta H. So what are you going to do? You don't have a delta HR, so you can't find the molar enthalpy of combustion. But these are the numbers they want you to compare. How can you find delta HR in this question?
Do you use the formula of like reactants and products and sign?
Yeah, it tells you. If you keep reading the question, it says, determine the amount of energy lost per mole when combustion is incomplete as written. The standard molar enthalpy of formation is this value. So they're telling you, you've got to use your molar enthalpies of formation. So your delta HR will be equal to the sum of the molar enthalpies of your products times the number of moles subtracted by the same for your reactants. So you've got 7 moles times delta HF for water, which is negative 285.8 kilojoules per mole. You've got 4 moles of carbon. You've got 1 mole of CO2 gas, 393.5, I think. And you've also got to add to that the molar enthalpy of formation for carbon monoxide, which I don't know off the top of my head.
CO2 is the negative 393.5, CO is negative 110.
Thank you, negative 110 kilojoules per mole. So there's my carbon monoxide. From this, I'm going to subtract 1 mole times molar enthalpy of formation for hexane, which they give you in the question. Plus 5 moles times 0. Figure that out, and you get a delta HR. So this is the enthalpy of reaction for the incomplete combustion. So to turn it into a molar enthalpy, you plug it into this formula, right? So it is negative 2,303.3 kilojoules per mole of hexane. So what's the difference in energy? Ballpark it. It's 41 minus 23. Too much? Too much math? Isn't it like 18? So it's 1,800 kilojoules of energy. You lose 1,800 kilojoules of energy per mole by having incomplete combustion. Because some of the energy is still stored in the carbon monoxide bonds. Okay? So, this is why you want to have complete combustion when you're burning a fuel. You get the most energy output, and you don't make things like carbon monoxide that are bad for your health. So, Bunsen burners. What color flame should it be when you turn on a Bunsen burner? Orange or yellow. That's incomplete combustion. The blue flame that you get when you're mixing oxygen gas in at the bottom by opening the hole, that allows you to have complete combustion, get a blue flame. If we have people working in the lab for a long period of time using a Bunsen burner and they turn it yellow when they're not right beside it, people will start to get a headache. And that's because of the carbon monoxide in the air. If your furnace is not burning efficiently, you start to get a carbon buildup on the jets, and then you start to get more incomplete combustion, which then starts producing carbon monoxide, which can be fatal, which is why every house now has to have efficiency. There's lots of factors if we're really going to look at efficiency, but we're going to look at it in terms of our textbook questions, not in terms of the bigger picture of how efficient is it for us to pay for our food, right? If we're talking efficiency, then we're talking about mileage. You've got to put in for gas consumption. You've got to put in everything that goes into the entire process of getting your fuel where it goes to. Okay, so it's a ratio. And it's basically how much energy was useful over how much energy was input times 100%. So ideally, you want a high percentage, although most things are a low percentage. So how much fuel we burnt, how much energy we got out of burning our fuel, how much was actually absorbed by what we were heating. So it could be your furnace. It could be your barbecue. It could be anything that burns a fuel. So there's a couple of steps you need to take. The first thing you need is a balanced chemical equation. You need to determine the heat absorbed by your materials. You need to determine the enthalpy change of your system. So how much energy you got from your fuel. So what do you think goes where in this equation? Where does Q go? Where does delta H go? Yep. Q goes on the top, delta H goes on the bottom, multiply it by 100%. Determine the percent efficiency. And we are going to make an assumption that we form liquid water. So our molar enthalpy of combustion is 2,220 kilojoules per mole. Properly, but we've got 200 grams of water times the specific heat capacity times 70 minus 25. The steel pot is 500 grams times 0.503 times 45. 58660 joules, 18108 joules, Q total, 76,768 joules. So that's how much useful energy was used, right? That's how much our water in our pot actually absorbed. Yep.
Is that number on the end there, 45 degrees Celsius?
Yes.
Just a question. The lower.
Our Q, we've got to figure out our delta H. How much energy was actually produced by burning 10 grams? 49 kilojoules. Delta H is, there's 10 grams. The molar mass, maybe, is 44 grams per mole. And negative 2220 kilojoules per mole. What'd you get? This is not going to be a very efficient propane.
Where are we multiplying
Barbecue.
the brackets by?
What number do you get? If you take the mass divided by the molar mass, what are your units?
H is moles.
Moles. Delta H is moles times the molar enthalpy.
Okay, so you do that multiplied by a negative.
Yep. So, what number? 49 kilojoules divided by 503 kilojoules times 100%. Wow. It's going to be about 10%, right?
Is the 503 negative?
We're not going to worry about it. Percent efficiency is always going to be a positive number. So? 9.74%. Not very efficient. How many people actually have a side burner on their barbecue at home? Do you guys use it? No, we don't either. So, Q total is 15,512 joules. So that's how much heat got absorbed. Sorry. What we have to do is work backwards to find mass. We know that this is negative 51.7 kilojoules. Negative, it's exothermic, because we're burning. We're burning a fuel, they're exothermic. We need to find N. We know this is negative 220, 2,220 kilojoules per mole. So we get a very small number, multiply that by the molar mass, and you've got your mass. So we're doing this backwards.
Where are we getting the, delta
Molar
H?
enthalpy of combustion for propane,
Oh, okay.
What's that number, is it 0.02?
0.2, I think.
It is.
So it's 1 gram. About 1 gram of propane burned in this high efficiency propane burning barbecue to heat a small cup of hot chocolate, 16 degrees Celsius.
22,201? Or is it
Point
2,220?
What? Okay, good?